Hi guys. Okay, it's Miss K here. At this point, if you're listening to me, you should have already gone through the warm-up and checked your homework. And then you watched the video on the Notice Wonder and you saw the girl's project where she was moving the water. And what you should have noticed was that when one emptied, right, the square emptied into the triangles and then vice versa. And I asked you a couple of questions that I do want you to continue to think about as we talk. But today we're going to kind of explore right triangle similarity, and we're going to explore the similar right triangles that are created. So if you go ahead and turn your page, you should be on page 56 with me here, looking at this one triangle. So they tell us that right triangle ABC is shown below. And then if you look right below that, they say that the altitude is drawn from angle C to the point D on the hypotenuse. And what they're asking us to do is to label the vertices of the three similar triangles that are created. So a couple of things I want you to think about. In a right triangle, and we've talked about this before, I'm going to go ahead and just label some things on my picture for you to see. But remember, we have a right angle on both sides, right? Because that's a linear pair. And in a right triangle, we know that the hypotenuse is directly across from the right angle. So I'm just showing you these arrows so that it kind of gives you a point of reference if you are confused about how to kind of extract them. All right, so our large triangle we can obviously see, and we can label that with A and C and D, okay? But then the second triangle that comes out of that, I want you to kind of think about the relationship, and I'm going to highlight it if I can on my screen. We're going to go ahead and look at this triangle, right? Think about this relationship that's created. D is our right angle, so I can go ahead and label that. But then when you think about it, the shorter leg, if you will, goes up to C and then the longer leg goes down to B. And then in the smallest triangle, and I'll go ahead and highlight that one as well, we have this smaller triangle. Okay, so again, our right angle is still going to be labeled angle D, but then the shorter leg takes us over to A, and the longer leg goes up to C. So as long as you can see that, you can now tell that we have three triangles that we're going to be using. Okay, so if you flip the page, this page is going to just ask us some questions. So if you want to take a minute and pause me and look at it and try to come up with some answers, then we can go through it and you can unpause and I'll still be here. So which angles have the same measure as angle 1? So hopefully you are looking at what I've drawn. If you're looking at my screen right now, you can kind of see that I flipped all the triangles around so that I could very clearly see what was happening. So in the top one, I rotated it so that the right angle is in the left corner. And then in the left triangle, I literally reflected it. So again, my right angle is in the left corner. And then for the top one, I just rotated it so that my shorter leg would be on the bottom. So now they all match. So which angles have the same angle as measure 1? It's going to be angles 1, 4, and 7. Which angles have the same measure as angle 2? That's going to be 2, 6, and 8. Which angles have the same measure as angle 3? Those are going to be 3, 5, and 9. And then based on our angles, what would be true, or based on our answers, what's true about the three angles? We know that these three angles come up to a sum of 180. Of course, that's the triangle sum theorem. And then we also know that the angles themselves are going to be congruent to their corresponding angles, right? So 1, 4, and 7 are congruent, 2, 6, and 8 are congruent, 3, 5, and 9 are congruent. And we know that's true because in every similar figure, we have congruent angles, but proportional side lengths. And that's the same thing that happens with these right triangles. So if we're using then in number 5, the diagram to complete the similarity statement, we can go ahead and say that triangle RST is going to be similar to triangle RWS, which is similar to triangle SWT. All right. And you'll notice the right angle is going to be W for the two smaller triangles. The right angle is S for the larger triangle. So we just need to make sure that they're lined up correctly. So which segment is the altitude to the hypotenuse? So if you're looking at our large triangle RST, then hopefully you automatically see that going right through that, dropping right down from the top of that triangle and forming the right angle with the base is SW. So that segment becomes the altitude of that triangle because it forms the right angle with the base, quote unquote, or in this case, the hypotenuse of the largest triangle, which is side RT. So the altitude to the hypotenuse of a right triangle divides that triangle into two triangles that are similar to the original triangle and to each other. So for the sake of making sure I don't run out of time, I'm going to stop here and then just do a quick second video that you can watch in that same link in the module.